everyone. This is Jonah Andersson, and thank you so much for tuning in to Azure User Group Sundsvall, Sweden's event today. It's weekend, but I hope that you're watching us live, or if you're watching this recorded, thank you for tuning in. And today I will be sharing with you about Azure Durable Functions fundamentals, which are important when you're developing serverless applications or functions in Microsoft Azure. So I would like to start by sharing a bit about Azure User Group Sundsvall. So Azure User Group Sundsvall is a user group that I started in February. I've had like few sessions already, and right now I'm actually running it by myself on my free time when on weekends. So I wanted to create a community network for all developers or IT professionals here in Sweden, especially in my area, to learn together about Azure technologies, software development, and cloud development. And it is intended to be a group that's open to everyone and to share knowledge and learned experiences. And if you are a developer, speaker, or someone that has something to share, and discuss through this user group, feel free to join the group through this link, meetup link, and also to connect with me. I am open for collaborative things with you, and feel free to connect. And the code of conduct for this group is to be nice and friendly, listen with a purpose, be respectful to different opinions of others, especially when there are live chats or comments going on. And seek to understand, not criticize, and be curious and open, and be inclusive in your comments and questions, especially during live discussions. I don't think it's too much discussions right now, maybe because the user group is new, but this is the user group's code of conduct. And let me start by sharing about myself. So my name is Jonah Andersson. I am a Microsoft MVP for Azure here in Sweden. And I am also an certified Azure developer associate. And I work full-time as a software developer consultant at Forefront Consulting, which is an IT consulting company based in Sweden, with main office in Stockholm and even one here in Sundsvall area. And I code full stack development in C# and .NET. This is the language that's close to my heart because I've also worked a lot with it, and I also love and passionate about learning and developing things with Microsoft Azure Cloud Platform. And on my free time, I like to share knowledge through mentoring and public speaking. And I also have some hobbies like reading books and playing chess. So if you have those hobbies, feel free to connect with me so we can play some chess or share good books together. And I would like to start my session by sharing to you about the queue problem. The queue problem at the airport. So a few years ago, before all pandemic happens, I believe it was in 2018. I was traveling alone from the Philippines from Sweden to the Philippines, and it was early in the morning, and I was in a long line. The self-service kiosks were not available, and I really wanted to grab a cup of coffee because I like my coffee in the morning. And I really wish that I could do parallel things at the same time in that situation, because I couldn't do that, because if I leave the line, I would lose my state or my status in the queue, and someone else will grab my line. So my point here is that My point is that we also experience parallel tasks or key problems in our software development also. And that's the reason why Azure Durable Functions can be useful for us, especially if you want to solve complex workflow problems in a serverless architecture. So as an overview, I would like to give you a quick introduction about what cloud computing is, an introduction to serverless, Azure functions, durable functions, and the different patterns for the durable functions, and a demo that I have, which is a mini project that is ongoing, and some learning resources. So cloud computing. So cloud computing, as we all know, there are different types of that. We have the public cloud, we have the private cloud, and we also have the hybrid cloud. In my previous session on the user group, I had an introduction to cloud computing session. So if you missed that, feel free to watch the recorded session, especially if you're new to cloud computing and don't understand what Azure is and the different deployment models. So here in Microsoft Azure is a public cloud provider, and in cloud computing there are different deployment models. We have infrastructure as a service, platform as a service. We also have function as a service, and also software as a service. And today we will be focusing on function as a service, which is also known as serverless, which means that, as you can see here, the dark blue layers here, this is where what the cloud provider Azure takes care for us, and we developers only have to take care about the functions and the data in our development. And what is serverless anyway? Serverless is a hype and a trend these days that everyone wants to learn more about it. It also goes in parallel with working with containers, Kubernetes, and that. But what is really serverless? So serverless means that it's a full abstraction of servers, which means that you as a developer don't have to worry, maintain those infrastructure and service. It's because there's a full abstraction of that from you and your team, because Microsoft Azure as a provider take care of the updates and maintenance of those servers for you. And with serverless, you can scale it. There's an option to auto scale it. It's instant. You can create it in a few minutes, and it's also event driven, which is perfect if you want to create something that are event driven in an application that is function as a service model. And it is not really serverless, so it might be misunderstood that there's no servers behind it, but there are actually servers or infrastructures behind it. It's just that you don't need to worry about it. And suite comparison, I would like to share serverless in comparison with the suite stuff. Especially, I like to eat desserts after a good meal, so I wanted to share the comparison of that. So when it comes to monoliths are like a layered cake with different layers in it in one place, just like our database server, web servers, and even our applications. So everything are in one place. They can be in data centers, hosted in data centers, and you also have the responsible to take care of everything of that, like backups and things. So they are like layered cakes. Everything is in one place. And microservices are like mini cupcakes. They are like different, and it serves its purpose at a time. And there's an isolation and decoupling going on. So if one service or one cupcake was used or eaten, then it's kind of like separated, and the other services can be used. So that's the sweet comparison of microservices. And there's also serverless. They're like candies, or we call it in Sweden goodies, where they are small and light, And when you have it after a meal, then you're already satisfied. So serverless is like it's easier, it's light, and you can pick it quickly. You can put it in your pocket. Just like also with functions, you can create it quickly. If you want to create like a function that listens to your Azure storage and process it with something else or other tasks. And when it comes to control and productivity, we see that in monolith architecture, we have more control, of course, but you have less productivity because you have to spend a lot of time maintaining the systems and upgrading them, make sure everything is working fine. And if one server fails, for example, your data server or your web servers fails, then your application won't work because of the monolithic architecture. And as we go farther to the right, to serverless, for example, serverless focuses more on productivity, which means that you don't have to worry about your infrastructure or servers, because you just have to focus on the productivity of the developers, which is we that's working on the code. So that's the sweet comparison, and I hope that you learned something about this comparison and I didn't make you hungry. So, why do we build serverless in Azure? It's because we cannot just we cannot just build something in Azure without knowing why. We always want to know, why am I doing things and why do I build things in a certain platform. So we build serverless if you really want to enhance your developer productivity, which means that your developer team or development team do not need to think about maintaining the infrastructures and the service behind it, but they can focus on what needs to be done in the functions or the business requirements that needs to be delivered. And you can auto scale in serverless, which means that you don't have to manually upgrade the instances or upgrade the storage, because it does it for you. And there's an option, the pay-per-use model, because pay-per-use model means that you can minimize your cloud expenses because you only pay for what you use, which means that when your function is cold and running, that's when you pay for it. So that's a good thing about serverless. It can save you a lot of money compared to the model infrastructure as infrastructure as a service, in which you need to maintain and pay for the uses of your virtual machine while it's running. And you can also develop intelligent apps with your serverless functions. For example, you can integrate it with machine learning, AI, and cognitive services that are available within Azure, and even external ones. And you can solve complex problems like the parallel task problems that I shared in the beginning about the queue problem, in which that you want to do parallel tasks, but you want to keep the state of your current task. So this is a good thing to have, a reason why you can consider serverless as well. And also seamless connectivity, which means that you can integrate it and modernize it with different services that's available within Azure. For example, you can integrate your Azure functions with logic apps, with Azure Service Bus, and even external services or APIs. So that's a good thing. So before I dig deeper into the details of durable functions, it's important for us to go through and find out what are Azure functions, because Azure functions is like the main service, compute service that durable functions are extended from. So Azure functions are a type of serverless computing service that's also considered function as a service. So if it is serverless, it supports different languages like C#, F#, JavaScript, even Java. and it is event driven. So if you are designing something that will be event driven or a function or controlled by functions, then this is a perfect serverless service to consider. And if you want to integrate Azure with if you want to integrate it with Azure, so you have, as mentioned, there's logic apps, others, service bus, and even third-party services. For example, in my demo, I used SendGrid and Twilio to send and receive SMS or make calls. So it's a really good way to integrate with other services, and it's pretty flexible. And Azure Functions. So Azure Functions is a code first approach, which means that you have the code and then you have the events and data, and then that's the Azure Functions. That's all it is. So it is a code first approach. What you need is just your lines of code or the logic that you need to do, and the events that will trigger that functions, and the data that you need to process from or to your applications. So that's Azure Functions. So there are different pricing models in for Azure Functions. The most common one is the consumption model, which is considered serverless, which means that you only pay when your code runs or your function runs. And there's also a plan, actually, pricing model, an app service plan for Azure Functions. This is if you want to control your monthly costs and you really need to use the app service plan, then it's good to have. And there's also a premium plan that's I believe it wasn't preview, but it shouldn't be now. It has a promise of maximum performance or the premium services that you might need extra aside from the consumption and the normal plan. So those are the pricing models, and I would like to compare about Azure Functions versus Azure Durable Functions. So Azure Functions, they're there, they exist, but they are stateless, which means that when you create an Azure Functions, because you don't have to take care of the infrastructure. So when you create one, they can be saved in any designated virtual machines or storage in the cloud, and when that virtual machine is restarted or due to maintenance or data maintenance or something that happens in the servers in the cloud, then that when the VM is restarted, then you loses its state. So that can be tricky, especially if you want your functions or tasks to be stateful. So this is the reason why Azure Functions has an extension called Durable Functions, which allows you to create a stateful workflow. So Azure Functions are stateless, and Azure Durable Functions are stateful. So there are two. They are the same, but these are like the main difference. What to use what depending on what it is that you want to solve, of course. So durable functions. So now we're into the main topic after the introductions and the prerequisite knowledge that's needed. So for Azure Durable Functions, as mentioned, it is an extension on top of Azure Functions. You can create long-running and eternal workflows that are stateful with durable functions. And you can also implement and solve complex stateful functions with this technology. And you can code it in several languages that's supported right now as of today. It's like C#, JavaScript, Python, F#, and PowerShell. And with durable functions, you can also create sub-orchestration within your orchestration that are stateful. And when do we need to use durable functions. So you cannot just use durable functions any way you want. It actually depends on what you want to solve, of course. So long-running stateful workflows, durable functions solves that. If you want to work with recurrence interval, and if you want to manage the life cycle of your tasks or want to control the workflow of your functions or your tasks, so that is a good thing to have. And if you're already running, if you need to run parallel multiple Azure functions, then it's ideal to use this technology. And if you want to retry function activities in case of failure, or for example, if you have the workflow in which that requires human interaction, then it's good that you can retry your activity function activities. And there's also with durable functions, you can also develop it locally. So there's an option to develop it also in the portal, but if you're a developer, it's an advantage that you can work on your serverless coding locally. So the technology behind durable functions, or the open source library that is on GitHub. It is a lightweight framework called Durable Task Framework, and if you want to learn more about it and check out how it looks in the code, you can visit or click on this GitHub repo for the durable task. And let's go to the different types of durable functions. This is the big picture. So there are three or four types, but the main ones are the top three, which are the client functions, the orchestrator functions, and also the activity functions. So the client functions, they are like the starter. They are like the entry point in creating the instance of durable functions orchestrator. And the orchestrator serves as the orchestrator is the function that describes the workflow on how your tasks or actions are to be executed. And this requires an orchestration trigger to be triggered, which comes from the client functions. So in this first part, the client function, which is considered a starter, kickstarts the orchestration, and the orchestrator can process the workflow based on which task that needs to be called activity functions. So they are like a normal Azure functions that performs its specific tasks. But what's special about this overview is that the client functions the orchestration can only be triggered by the client functions. So using the orchestration trigger. And as for the activities in the orchestration, these activities, Azure function activities, can only be triggered by an activity trigger that was called from the orchestrator. And as for the client can be started or triggered with an event, for example, an HTTP event or trigger, a BLOB trigger, a Service Bus trigger, or an external event that kickstarts this, and it kickstarts the whole orchestration and workflow. So those are the different parts, and there's also a fourth one, which are called entity functions, which are used for durable entities. And it uses entity trigger, a special type of trigger. And they are only available in two languages, .NET and JavaScript, and only supports Durable Functions 2.0 and above. And the orchestrator. So the orchestrator is the most important part of the Durable Functions workflow. So the orchestrator, it is important that it is deterministic. What is deterministic? Why does it have to be deterministic? It's because the whole function, orchestrator functions, or workflow will be replayed. So it is important that when you design or code your orchestrator, they are like determined and have this planned workflow. And if you want to learn more, the technology behind the orchestrator uses the deterministic API. So if you want to learn more about deterministic APIs, you can check out this Microsoft documentation on the link, or you can also Google it directly. And here is a good example of a set of functions in deterministic versus non-deterministic. So as you can see, these are like the durable functions with an orchestrator. You see that the workflow is like arranged and planned. This is an example of function chaining, for example. So you have it like a workflow. It's planned, so they're triggered by the orchestration. And here on the right side, you have the non-deterministic example, which means no workflow functions, like normal Azure functions in our application that are serverless. So when you create this, for example, you create one function first, and they can be saved in a virtual machine in Azure, and this one saved there. So they run separately. So if you don't need a workflow, then it's good, and you don't want to keep your state, then this one, non-deterministic flows are good. But if you really want a stateful workflow, then a determined orchestrator is what you need. So there are different constraints for designing your orchestrator workflow or orchestration in durable functions. So I created this list of do's and don'ts orchestrator rule. So the first one is that don't create a random numbers or GUIDs within your orchestration or orchestration function. It's because it breaks the rule. It breaks the rule of the orchestrator being deterministic. And what you can do instead, if you really need to create random numbers or GUIDs for your data, then you can you can retrieve or work on this data in your activity functions. And of course, don't use access data stores like database connection strings or configurations within your orchestrator client orchestration function, because it is not advisable. It's also not, it is like a data that can change, especially if you have like a SAST ID in it. So it's good to work on your configuration also in activity functions and not process it there. And there don't use thread actions like sleep, run, or delay. Because it breaks the purpose of the orchestration function. And what you can do instead is use the durable orchestration context that have good functions available to be used for orchestration purposes. And do not create infinite loops within your orchestrator function. Even though durable functions are designed to run eternally, like forever, it doesn't mean that we can recreate a loop within a loop. What I mean is that it is not advisable to code for each loop or loops that are infinite, because it first is that it will be complex and it will create problems and errors in your orchestration. And also, if you know, it will also create problems with your consumption plan, your bill. So if you're running that, it might work, but it might cost you to pay a lot of bill. So try to prevent creating infinite loops in your orchestrator function. What you can do instead is make use of the durable orchestration context and call the create as new method, which is useful also and is used for creating eternal orchestration, like a process or workflows that runs eternally. And don't use current datetime because it breaks the rules of being deterministic. Time changes milliseconds all the time, so don't use that in your orchestrator because it changes. I mean, the dates changes. So what you can do is use the durable context and call the current UTC datetime instead if you need to process some data types. All right, so those are the rules, do's and don'ts of durable functions. And now let's go to the different patterns. So there are different patterns that durable functions help us and can be used in our workflows. There's like, first one is the function chaining. There's the fanning out and fanning out and fanning in. And there's the Async HTTP API. There's the monitoring pattern, human interaction pattern, and also external events correlation pattern. So the first one is the function chaining. So in function chaining, the sequence of function executes in a specific order, just like a chain. So function 1, function 2, function 3, and function 4, as you can see in this illustration. So what it does is that the output of the first pattern, becomes the input of the second the output of the first function, it becomes the input of the second function, and then the output of the second function will be the input of the third function. So they run in sequence, but they depend, the values of the next function depends on the first one. So just like a chain. So in this example, this is an example that I got from the Microsoft documentation site. So you have a chaining example in which you have the durable context and a try-catch here, and you have functions x, y, z, and here on the first variable x, it doesn't take anything as a parameter, but then on the variable y, you call the activity function called f2 that takes the result of x, and it goes the same way for variable z that takes the output of function 2 and send out the result, which is the parameter y, and so on and so forth. So that's function chaining, and this can be useful in many scenarios, use case scenarios, so that requires input and output from different tasks or resources. And this is function chaining in action, so just to give you a better understanding how it really works behind the scenes. So for example, when the orchestrator was started, it can be in any type of trigger, for example HTTP trigger or storage trigger, BLOB trigger. So when that orchestrator was started or kick-started by the client function, what happens is that it schedule activity 1, and when activity 1 is scheduled, the orchestrator sleeps, and when activity 1 is done, the orchestrator wakes up, and then it schedules activity 2 for processing, and then it sleeps again, and then when activity 2 is done, the orchestration is completed. So this is the entire, like, the function chaining in action in a simple example. So which means that this is a good example because we see that the orchestrator likes to sleep, and sleeps and wakes up, sleeps and wakes up. But the orchestrator is very active. Like, he doesn't sleep as long as we do 8 hours a day, but it's pretty active and it sleeps. And the good thing when the orchestrator sleeps is that you don't have to pay for the activities or the tasks or the functions that are not being called by the orchestrator, and which this means that it gives us more control of our workflow, and we don't need to worry that other functions are running in the background and our Azure subscription bill are getting high because you don't have no control about your serverless flow. So this is a good example of function chaining as an example. So Orchestrator is not just deterministic, it also likes to sleep and keeps waking up. So I hope you learned something about this illustration. And the next pattern is the fanning out and fanning in. So in fanning out and fanning in pattern, you execute multiple functions at the same time in parallel, and then wait for all of those functions to finish and aggregate the result of those tasks into one and process it later. So in this code example, there's it's called backing up the site content. This is from the Microsoft documentation as well. In this example, you have a function orchestration to back up a site content, backup content, and you have a files, and you have a loop here that loops through your files, all tasks. So it's gonna copy to the files to the blob, and then when all of those tasks are done, it uses the keyword or the method called when all and sends the completed task. And when all of that is done, then it processes the result farther. For example, doing a sum or total of the result. So next is Async HTTP API. Async HTTP API exposes a synchronous long-running process over HTTP. So if you want to do async HTTP functions or tasks, then this is a good one. For example, in my code snippet here, I have a function called check if a check website is available, and I have the context, the durable orchestration context, and I'm getting the durable HTTP response by calling HTTP async. And in my HTTP async method, I send in what kind of method that I want to have in my call, and then I pass in my URL, which is my website, jonahandersson.tech, and I do a if condition that checks the status code. If the status codes are not good, then I throw an HTTP request exception and throw in an error. Otherwise, I can process it further. For in this example, I just wanted to print the HTTP response content in my console. So that's an example of async HTTPI. And the next one is the monitor pattern. Monitor pattern is the opposite of async HTTPI. It is the opposite, but it's also good because it's commonly used for monitoring. For example, you can perform recurring process and set a timer for that. In this example, there's a monitoring job status, and in here you have an expiry time in your while loop, and you have the condition that if the status is completed, you call another task called send alert, and you send your machine ID, and then while it's doing that, you also can set timer and pulling interval, and also a cancellation or next check. So this is a good pattern for monitoring recurring processes or tasks, and you also want to use some timer on that. And next is the human interaction pattern. In human interaction, it is special because it is the orchestrator. The orchestrator waits for external events. This is good to use in use case like or use case that requires approval workflow from a real person, or if you need a timer, or if you don't want to process the approval until a specific period of time. So this is a good example. if you want to work with a response, if you want the orchestrator to wait for external events. So in this example, we have a function called approval workflow, and in this we have a due time. It's just like this is like the current UTC datetime. This is the one of the dues that I mentioned earlier. So you can use the current UTC datetime to set your due time and the timeout. And here you have a condition that when the orchestrator waits for the approval event. So it uses the task, the syntax task when any. So it waits for an approval event with a timeout. So when the timeout is over, then what it will do is that it's gonna escalate. Escalate the process so that your entire workflow don't need to wait for that person that's supposed to process the approval. Probably he or she is busy, so you can design it that to escalate it further if you don't get a response. So next is the aggregator pattern. So the aggregator pattern are commonly used for stateful entities, which means that you aggregate event data over a period of time into a single addressable entity, and this is commonly used for durable entities. All right, so next is the different types of orchestration details, especially in the HTTP API. So in this example, I had it a screenshot from Postman with an HTTP trigger or request. And when you do that, when you run it with durable functions, you actually get good data or information, which doesn't only show in Postman, but also in the logs in your storage for the Azure durable functions. So you have the orchestration ID, which is important, and you can reuse in your orchestration. We also have the URL instance, and also raise event URL, terminate URL if you want to terminate your orchestration, purge history URL if you want to purge or delete the history, delete your orchestration URL, and also if you want to want your restart post URL. So this is a good information to have, that you have this when you want to control your workflow behind the code. All right, so to those that are interested in Kubernetes, their Azure functions can be used in Kubernetes as well. There's a service called KEDA, Kubernetes-based event-driven autoscaling, that helps you pair Azure functions runtime and use it with Kubernetes. So you can, I'm not expert in KEDA, but if you want to learn more about KEDA, you can click on this link, Azure Functions and Functions in Kubernetes KEDA. All right, so as for the .NET 5 durable function support, currently the normal Azure functions are already supported in .NET 5, but for durable functions and running stateful workflow, as of today, it is the .NET Core 3.1 that are supported. But it was announced in .NET Focus event a few months ago that the durable functions will probably be supported in .NET 6 preview. So it is something that are worth checking out when it's available for the next .NET. But currently it's not available for .NET 5. All right, so best practices for durable functions. So there are certain best practices. We have you can use Azure Application Insights for monitoring the instances and the health of your functions. And it is also good to version functions consciously, because for example, durable functions, they are long-running workflow, so it's not good to interrupt what's in production. So what you can do is you can do side-by-side deployment, and deployment with breaking change. So you can use deployment slots in Azure to create different environments and switch and swap to do a side-by-side deployment and not interrupt what's in production. But I know that this is a challenge for many to develop serverless because of versioning challenges. And also make use of the Azure Storage Explorer that I'm going to show in my demo as well. It's a good thing to have if you want to know the history, the logs of your instances, what's going on with your workflow, or if you want to cancel it or purge, delete it. It's good to have if you want, especially if you're developing locally. And Azure Storage Explorer also is in the cloud or is in Azure Portal if you prefer to work on the web browser. And I would like to recommend an article in Medium about durable functions, blue-green deployment strategies. It was a good article, so if you have time, you can take a picture or search on this on Medium. The author describes the different ways and challenges for deploying durable functions in serverless. So definitely worth checking out. So error handling. In durable functions gives us, for example, if something goes wrong, you get a function failed exception. So what you can do to handle that is you can call another function activity. You reuse the method called that's ready. Actually, there's an automatic retry called call activity with retry async that you can access through your durable orchestration context. And you can use the traditional try-catch blocks error handling as well. All right, so here's the automatic retry looks like. So you have a timer with the retry. So instead of just using context call activity async, you use instead the call activity async with retry. So you handle the error automatically in one line of code. But what you would need is that aside from sending your function name, you would also need to set up your retry options. So in this case, your retry options is that you want your first retry interval to be after 5 seconds, and the number of attempts would be 3 times. So that's an example of automatic retry. And next is the try-catch blocks with calling other functions, calling out other activities. So in this example, we have transfer funds. And in here, we want to debit the account when something comes in and transfer the source, the amount to the source account. But in this case, if something goes wrong, what you can do, if something fails in your orchestration, what you can do is you can catch that and handle it by calling another activity, call activity async. So if something goes wrong, you can credit the account back to the source account where the money came from. So this is a good way to handle possible errors in your orchestration. And also you can unit test durable functions using mock framework and XUnit. So here is an example on how you can test an orchestrator or sequence. So for example, you can mock the orchestration just like how it is on the orchestrator and assert the results and run the test this way. So there's a link here. So if you search durable functions unit testing, you will find a few examples as well as testing activity functions separately. And for developing Azure functions, there are several ways to do that. Of course, you can do the easiest and the quickest one. You can use it on the Azure portal. You can use the Cloud Shell on the portal, but you can also use develop it locally using Visual Studio and VS Code. And you would need Azure Core Tools, Azure Functions Core Tools that you can download from this GitHub link, and also Postman if you want to check on the status or information of your web request locally. So you can use the web browser, Postman, and for local development, I usually use Azure Storage Explorer for that. So this is good if you want to see the logs and what's going on in my orchestrator and its instances. And as for learning resources, of course, we have the Microsoft Learn or the Microsoft documentation. If you want to get started, especially if you're new to this technology, this is the first step. Go to Microsoft Learn, the documentation. And I would also recommend Azure Functions University on YouTube. It's one of the YouTube channels that I follow by Mark Tucker and Gwen Pena Sequenza. It's the YouTube channel is called Serverless in Azure, and here they have like create lessons from the basic information that you need to learn about Azure Functions, and also the advanced level for durable functions and some real life examples. So definitely check this YouTube channel out. And I also created an article on Dev community about durable functions, so you can check that out on this link. So developer tools, these are the most common ones. As I mentioned already, you can code with, since I'm a C# developer, a .NET developer, so these are the ones that I know, but definitely those that are coding in other languages probably have different tools used. So these are the main ones for my side. All right, so I will be showing you a demo. Now let's see how we can do that. Let's see. Let me just stop sharing and share another screen. This one. All right, let's see. Let me open this one. I hope you can see it. All right, so here is my example. First, I would like to show you. Which one was that? Okay. All right, I would like to show you first this one. Sorry. I would like to show you first what I was trying to do. All right, so this is what I'm trying to do here. Let's see. Sorry about this one. All right, this one. All right. So let me just first explain before I start doing a demo what I'm trying to do. So what I've tried in my demo project, I want to I want to create an orchestration which I called Serverless Azure Storage Notifier. It is a function chaining pattern that runs in the back end. And wait. All right, so in the back end, so I have like a client function called Azure BLOB that kickstarts the orchestration, and it is triggered. It is an Azure BLOB trigger, and what I send is the cloud blob data, and that data is an image. So when I upload an image to my Azure storage, it will trigger the client function, and the client function will kickstart the orchestration or the workflow. And in my orchestration, I have several activities that uses the function chaining pattern. And when the orchestration started, it would take the cloud blob data via the durable functions context, and then when it's taken, it will send in and call call another function, activity function called send message to the service bus, and passing the compose message with the blob data or URL. And then when that data is saved in the service bus, it will get the orchestrator get a confirmation that it was saved and sent to the service bus queue. And then when it's done, it will be sending an SMS and call me as an administrator of the application that, hey, I got a blob, new blob added to my storage, and it was saved on the Azure Service Bus. So I was using Twilio for that, for the SMS and call service, which is an external API. And then when it's done, I will be passing that information to another third function, which will send an email to me, an administrator, using SendGrid in Azure Service Bus. And then I have another function that gets read the message from the Service Bus queue and email it further. So this is just like a prototype or an example of how you can integrate different services or even external services with your serverless orchestrator. I know that I could use it. I could only need a few of this, but since I'm doing this for demo purposes with different services, I thought this would be a good example. So I will be sharing with you my code now. So in here, I have my blob start, which is BLOB Trigger. And when I upload my cloud blob, I will be checking if it's good, it's not null, and then I will be starting my orchestration using this in line 375. I will be starting my orchestration using the start new async by calling the orchestrator and pass in my new uploaded blob item within to the orchestration. And my orchestration function looks like this. I called it Azure Storage Notifier Orchestrator, and in my context I have my uploaded blob information that I saved and received using the context get input method via the context. And here I have my first chain. Send a message and compose a message to be saved to the Azure Service Bus queue. I passed in my uploaded cloud blob info, and I have the second chain in which that if this is done, it will be sending an SMS and calling me using the Twilio API. And when it's done, then it will be receiving or getting those Service Bus queue messages from the cloud, from Azure, and then send me an email. And then when it's done, then I will be getting like a final log or message in my console that it is already done. And in my Azure, I actually have a namespace. Here I have a namespace called Azure Durable Functions Demo, and I have a queue here, and in my queue I have this Service Bus queue called that, and in here I have my service bus. Here I will be receiving the message. So I will be running the code now. Let's see. Run that. So I'm running it. So I have this in the background. Wait, it already started. Okay. And I have my Azure Storage Explorer, and in here I have to restart. Wait. So restart. I was testing earlier, so I just want to make sure that it starts from scratch. Right. So this is my Azure Storage Explorer connected to my Azure account, and it's running now. And what it will do, it should trigger the orchestration, and it will go quick once I start this. So I will also have my telephone, my mobile on, so you hear it when I get a call from my application. Hope it works, because the last time I demoed this I had like technical problems and it was a challenge. All right, so I will be uploading this image to my blob. It is saying that it's transferring. And hopefully when it's done transferring, it will kickstart this without any problems. So here you can see that the orchestration has started, and it's done already. So I'm getting a call.
You have a trial account.
I have a trial account in Twilio, so I have this.
By upgrading to a full account. Press any key to execute your code.
So it should tell me the message, and I sent.
Hi, Jonah. Call reminder. New blob added to Service Bus queue.
All right, so that was like a call reminder to tell me as an administrator that a call was added, but it should have been without the trial error, a trial message, of course. But as you can see in the log here, it executed first. Let me see. Let me just maximize. Maybe it's hard. Let's see. There. Right. So I have this different activities here. So we start, for example, I have a blob trigger that can be triggered by the blob. This is like the starting point. And then the blob trigger kickstarts the orchestration, and then I have different activity triggers. So when I uploaded, it gives you this information that a new blob was detected in the name of my container in the Azure storage. And it gives me the trigger details, and here the orchestration was triggered by blob trigger, and the name of the image that I uploaded as a blob is this, the name of the file, and it started. The client function started the orchestration, and here it executed this one, executed the orchestration, and did send the message using Twilio, and process the message to the service bus, and sent a message to me, an SMS. I also got it, and it also sent me a call. So if we double check on my Azure portal, refresh it, it went so quick, so we wouldn't be able to see that the message was even here, but you can see on the metrics using the Azure Monitor in the Service Bus queue that there was a message processed just like a few minutes ago here. So messages that were outgoing. There was one incoming and one outgoing. So that's my demo is about. So I hope that you learned something. Let me just switch to my presentation again and go to the last part. Let's see. So the live demo results was this. So I got, when I run my orchestration, I uploaded the message or the blob to my Azure storage. I kickstart my orchestration. Then I got an SMS and an SMS from my orchestration using Twilio API. And then I got a call as well, just exact the same time, just milliseconds interval. And I also got an email on my mailbox. So that's the simple demo that I had. I hope it's useful and useful example to get started with durable functions and gave you an understanding on how it works. And to summarize, before I end, we're out of time. I just want to say that we learned something about serverless, Azure functions, and durable functions. And also, if you want to have a copy of the sample code, you can visit my GitHub or just click on this repo link, and you also got some useful resources to get started coding and learning about Azure functions and durable functions. So I would like to thank you so much for tuning in today. If you're watching live or recorded, thank you for watching. I hope you learned something. Please join and register to Azure User Group Sundsvall's meetup group if you want to learn more about the upcoming events, and also follow Azure User Group Sundsvall in Sweden. It's at Azug Sweden on Twitter. And here's a link to the copy of my code. All right. Thank you so much, and have a great weekend, everyone. And I hope to see you again at the next event. Bye-bye.